Here we go. So we talked about what a piecewise function is. Who can tell me? I think we wrote this down. What is piecewise?
Function that uses output depending on input.
All right, we're going to have, it's weird looking. It is a function. And we're not going through all of this. Like we're going to pick up where we left off, but I want Morgan and Maya to at least see this. Function that uses different mathematical, oh, come on, pen. There. And remember, I did not write out mathematical. Mathematical. I want it right. There it goes. Rules to define output. Output, which is your Y, depending on the input. So in other words, you're going to have 2 or 3 different graphs on one coordinate plane. They may or may not be connected at all. And the first one that we did, we graphed x plus 3. So when you see piecewise written, the first part is your equation. And it can be absolute value. You can have square root. You can, any of the ones that we've done. And then notice these are constraints over here. And that's going to be how you define the graph. So you're going to have some parameters with it. Where x plus 3, and this is what we looked at yesterday, or last time we met. X plus 3 starts at 3 on the y-axis, and it has a slope of 1. So it went this way, and everything was great, except x has to be less than or equal to -2. That is like, if you can't have it greater than -2. So we go find -2, which is the number right here, and it has to stop right there. It can't go any higher. So we go back and erase if we were any higher. And then you draw your graph. This doesn't have you stop anywhere else. So it's going to go all the way to infinity. But that's as high up as it goes.
Wait, are you talking about high up or to the right? Like
it won't go any further into positive land.
Is it that way?
Which is that way. Which is,
Okay.
and then you have -2x plus 5. So we're going to go to positive 5. I'm going to change color. And we have a slope this time of -2. So 1, 2, 1. 1, 2, 1. But it has to be greater than -2. It tells us that right here. Okay? So I'm going to still travel up. 1, 2, 1. And it's always, this is the x. Okay, here is -2. Can't be equal. So it's just greater than, so we put a circle there. And then it just keeps traveling as we go.
So why is it a circle right there? It's not a circle with the purple line.
The purple was or equal to,
Never mind.
and then that's greater.
I didn't see the or equal to.
Yep. And then, hold on, let me move my graph over. And then we draw. Okay? This graph only has two, piecewise, only has two pieces that we're working with. Now, we've got to figure out the domain and the range. Domain is how far we go left or how far we go right. It's about the x value. So, if we start over here, we have an arrow. Okay? So we know we're going to at least start in negative infinity. Now let's see how far we go across the x-axis. It ends right here at negative 2. But where did it pick up on the other graph? Do we have a negative 2 involved? We do, but it's all the way up here. So did we ever have a break going across the x-axis? No. Now, it ended there, but it picked back up there. I know one was a circle and one's a fill-in. The fill-in trumps the circle, okay? It allows it to be a part of it. So then, let's look. So we know it's going to go all the way down here to positive infinity. All right, does that make sense? Then we got to look at your y-axis to figure out the range. We know we have arrows down here. So it's going to at least start in negative infinity. How high up the y-axis does it go? All the way up here to 9. Did it include 9 or was that a circle? Circle. So it's a parenthesis. Okay? Does everybody have their handy dandies with them? The big ones? You're going to need that, and not just yet, but almost.
Do you do like the dotted line, solid line for these? Like,
These are all equal, so they're all solid, and we don't shade. We just stop at some point. Oh, I know why you're asking that, because of the constraint. The graph, these are all f of x and y equals. So your graph is this. Your constraint is the boundaries of your graph. The less than or greater than tells you where to stop or start your graph. Does that make sense? I think Hensley was asking, maybe?
oh, I don't know.
Okay.
That was it.
All right. I thought you looked at her and then asked. Okay. Does that make sense? First part's always the graph. It's going to be in brackets with the f of x or y equals, depending on how it's written. The second part is where it tells you what not to do or how to fix it further.
Can you graph the third one on number 3? Would it just be if your y-intercept is 1?
Third one on number 3. Almost.
Or would you put the dot on 5's 1?
That would be negative 5.
Wait,
5, 1.
so I put a dot on 5, 1?
Mm-hmm.
Is
But
our quiz just gonna be like how long 1 and 2 are? Or is there gonna be 3?
wait, what now?
Is our quiz just gonna have to be like how 1 and 2 are? Or is there gonna be like 3 and 5?
I don't well, 3 just is 3 different things.
Yeah, but I'm confused on how to plot the third one.
Okay, we'll get there. See, we did number 2 yesterday, I think, didn't we? No, it's more than that. We've got one more thing to do today that is so stinking easy, you're going to think, what? You just round down, okay? Remember the word round down. Got me? Round down. Okay.
I actually have to do this.
All right. We graphed this one yesterday, didn't we?
Yeah, we already did that one.
All right. So I'm going to move past it. Almost. Let's see, 4, 8. So like 2, I'm going to try to set it up so Morgan and Maya can see. 2x minus 4, it would start at negative 4. It has to be less than 4. So we know it will include a circle right there. And then slope was 2, positive 2. So we did 1. And we would draw a line. And then you had 11, but we have to be greater than or equal to 4. So you would have, it's at 8 when it became that way. If we go any of here, like 11 is going to be at 0, and that's less than. And then 5, 8. And we would draw that way. So what would your domain be? And so there's a break, but they're still on the same y-axis, so nothing changed. And then 8 bracket. All right, now for number 3. All right, first, did that make sense? I know I kind of went fast, Morgan and Maya. Beauty shop time is over. All right. So this one, we have a graph. The first one says -2. This, remember guys, this is like d of x. That's like y equals. What do you do when it's y equals -2? What does that look like? Horizontal. It's our constant. And it crosses at -2. All right, so we know we're going to at least start there. But it says x is less than or equal to -5. Ma'am.
The letters doesn't matter. They're always like Y.
Yeah, it's something of x. That'll be y. So what about the constraint? X is less than or equal to -5. What do we do?
Raise anything above.
And we're only horizontal, and it's or equal to. So we're going to go to -5, make a circle, and it's going to go that way. And I can erase that. Does that make sense for that first one? The second one, we're starting at 5, and our slope is 1. So we have x is less than 3, but it is also greater than or equal to -3.
Wait, why on that one did you go on the y-axis and the other one you went on the x?
Because it's y equals -2. So that's like a horizontal. And so but it said it had to be less than or equal to -5. It would be the whole thing, except it can't be greater than -5. All right, so if we have x is greater than or equal to -3 and x is less than 3 for our second one. So we have 5, and we know the slope is traveling this way. It has to be less than, x is greater than or equal to -3. We got to -3. So, and it's a fill-in. But it has to be less than 3. So we can go up here, and then when we get to 3, it's a circle. And that's what we put for that one. Does that make sense?
Wait, that's,
Okay. Do I need to talk about it any further? Are we good?
is that not 2? Not 3?
Wait, what now? No, I mean just those two. Now we're going to do the third one. I think this was where Mercy went help. So that's why I was...
Like, where you put that open circle, do you not put it on the 3?
Yeah, you put it on 2.
Did I put it on the 2? Oh, thank y'all. Erase. Thank you. Right there. And we'll go. Wait, no, I didn't.
It needs to be up.
It needs to be up.
Move up one.
There. I didn't do my slope. Thank y'all. Keep me straight. And, okay. Now, the next one is, what is the vertex?
5, 1.
So positive 5, positive 1. 5, 1. What kind of graph is this going to be?
Parabola.
It's not a linear, it's a parabola. Excellent. And what is the A value? 1. So we can use the 1-3-5 method, right? So we have to, x has to be greater than, I'm going to erase this part, greater than 3. So far our vertex is greater than 3. So the side over here is going to be easy. 1 and then 1, 2, 3. 1, 2, 3, 4, 5. All right, we know that's going to work. We go over 1, up 1. Over 1, okay, up 2, 3. That's on the 3, and so it gets a circle.
Wait, how do you know to use 1, 3, and 5?
That's just our method for parabola.
So you
Because the A value right here is a 1, positive 1. So you don't have to make a table. It's just easy to just graph it, find your vertex, then go over 1, up 1, over 1, up 3, over 1, up 5.
wait. So it'll always be like that for any equation like
Parabola.
How do you know if it's parabola?
Square.
If it's squared and it's a negative, it's positive, right?
The X part, the opposite HK? Yeah.
That's how
So
we
that's why you did positive 5.
Yes. And it has a positive A. If it had a negative A, we would have done a frowny face.
So then for 1 through 5, it's up 1, 1, and then it's up 3.
Like over 1, up 1, over 1, up 3, over 1, up 5.
So you always use the 1, 3, 5 thing whenever it's a...
When it's a parabola.
But
Now, if it's a frowny face, like a negative A, then you would go over 1, down 1, over 1, down 3, over 1, down 5. If the number for A is 2 or 3 or 1/2 or whatever, you multiply 1, 3, 5 by the A value.
so you only do the 1, 3, 5 if it's nothing there.
But then you can use the 1, 3, 5, just manipulate it, making it wider or flatter.
Yes, ma'am.
All right, so this will be our graph for this one. Now, if you don't remember 1, 3, 5, or if you kind of hesitate, then just make a chart and fill it in. You can do a table and just have your number -5, square it, and add 1, and you would get there. All right, domain's a little different on this one. It's not just, we do have 2 arrows, one going that way and one going up. But it's diff. We have breaks. So our domain is going to be choppy. Where does domain start? Negative infinity. When does it stop? On the x-axis.
10.
No, when is our first break? -5. Like when we have at this point we have a domain being included, but we don't have anything at -4. Do y'all see that? So we have to have a break in our domain.
This is where we use union.
This is where we use union. And so we'll have a -5. Will -5 be included as a bracket or bracket?
And then U.
And then a U.
-3, 8.
A bracket for -3.
Wait, would it not just be infinity then?
To 8.
Since those two are in the same line?
-3 all the way.
So positive.
To 8.
If this line is going that way, it's still going that way.
But we're still on +3. And even though it's a break,
So it would just be infinity.
it would if they were filled in.
So since they're open, you have to put it there.
Mercy.
If they weren't filled in, if they were solid, we could leave it. Or if one of them were solid, we could leave it.
So
But they're both circles, so technically 3 is not included.
So it would be a 3 parentheses.
So we would have, I'm going to write it down here so it's not written on top of the graph. You would have -3 is in a bracket, and you would have a 3 in a parenthesis. Because it is less than or equal to, less than 3, so like 2.99. And then the next one's greater than 3, which is like 3.25.
So then would you do parentheses 3 infinity?
Yep, and then we do parenthesis 3, infinity, enclose. So do you, oh, and I'm going to erase that first part. But do you see why it can't be from -3 to infinity? Again, if one of those had been filled in, it would have been. What's our range? Range is kind of different too.
Negative 2 infinity.
All right, let's see. We travel up our our y-axis, and we get to -2, and it happens. All right, I'm going to write us a -2 out here. Is there anything at -1?
0.
Is there anything at 0? So we can't just say -2 union positive infinity. When do we start using the y-axis again? 1 over here.
And then it would be 1 infinity.
So this is like, and was at -2 was a fill-in. So it's a bracket.
Wait, do you not do negative 2 comma 1? Why is it not a 2? Like, why is it not 2 things?
Because it's not where it's graphed. It's just what's happening on the y-axis. And it just stopped at 2. It was this. It stopped at 2.
So if it were to like be a line that went up.
We would do something else. And then this will be 1. Is 1 part of it? Yes. And then positive infinity. Okay. Trying to decide whether to break out. Okay. I'm going to stop right here, take us to the next part, and then we're going to come back to this sheet. So don't put it up forever.
Where does he get clicked backwards? 1 to infinity. Because there's something on
The parabola,
Um,
right there. I know, it makes me go, oh, well, it's an X value, but but it is over there. Don't put away whatever it is, but the sheet you have, because we still have one more thing to do with it. All right, does everybody have special functions? This is super, super easy. Put your calculators up for just a sec. Don't have them out yet. All right, everybody has this? All right, what we're looking at as far as the special function goes, this is called the step function. And what we do with step, I think this first is we're going to make little horizontal lines, but they're going to step. All right? Now, this is like the first one. And I think you can tell me the answer before we graph it. We have an auto repair shop, and he charges $60 an hour. But if you go in there and you use his company, his shop for even 10 minutes, what are you going to pay? $60. I don't want to visit him. You still pay. It's or for any part of the hour. Okay? So if you're in there for 10 minutes, it's $60. If you're in there for an hour, it's $60. What about if you go to 2 hours? 3 hours?
120 plus 8.
Yes. So what I did,
That was right.
you were right. You had to go figure it out. You didn't even have a calculator.
Yeah.
we're going to change the Y numbers, the units, and I'm counting up by 30s. So 30, 60, 90, 120, 150.
Just a little bit on the first. You know people can overdose on calls. Thank you.
Mm-hmm. 180,
Cough drops?
It hurts, like, if you take it.
210,
Like at once or like?
240,
A lot of people drink the syrup.
270. Okay, y'all, back here. All right. So we're going to, and the bottom is hours. So when I walk in that shop, have I paid him anything yet?
No.
No. So here's how we're going to work it.
Wait, I'm like,
Do what? I changed my numbers going up because we can't even, if we use 0 to 10,
so would number 8 be 270?
your 8's going to be 240.
240, 270, 300.
Yeah, there we go. So what happens at 0, we aren't paying him anything. But we need to, but 1 hour is going to count. We're going to pay up to 1 hour. How much? $60. So I'm going to go to my $60, which is 2. I'm going to do a circle because I hadn't paid him anything. And then I'm going to go all the way to 1 and put a dot. Okay? 2 for up to 2 hours. What we going to pay? 120? So we're going to go, but what if we are in there like 1 hour and 10 minutes? How much are we going to pay?
Oh wait.
We'll still pay 120, right?
So it would be on the dot.
So we're going to go above, we're going to go up to the 120, and I'm going to put a circle at the 1. And I'm going to go all the way to 2 and put a dot.
It's not if you're in there for 2 hours.
I mean, because if you're in there for 2 hours, you're going to pay 120. But if you're in there for an hour and a half, you're still paying 120. Because it says, or for any part of an hour. Which I don't like this company. I don't want to, I want to be able to pay in increments, like partial. So 3 hours, that's going to be 180. But if I'm in there for 2 hours, 10 minutes, I'm still paying 180. So I'm going to run up to 180, which is at the 6, and I'm going to do a circle, and I'm going to go over to the 3 and put a dot. And then that same thing for 240, we'll put a circle, and we'll go over and put a dot. All right, so do you see how and why that's set up? All right, this is the weird part for our step function. When it's a real world problem like this, it is always circle and then a solid. A circle and a solid. A circle and then a solid. And notice they go straight up above. All right, does this make sense in relation to our auto company? All right. Then we're going to look at just the pure thing. All right. Greatest integer function. This is still a step function. Okay? In other words, we're going to have a graph that looks like this with these little stair steps. But what we're going to do, the greatest integer function, what kind of number are we going to use? What kind of number are we going to use in greatest integer function? An integer. But sometimes we're going to end up with numbers that aren't integers, but we have to use an integer. So every time you end up with a fraction or a decimal, you round down. Are you listening, Hensley? Because you've got to understand this. You've not worked with this before. All right? So your greatest, I'm going to put it just your GI, because this is greatest integer function, your GIF, if you will, is always less than or equal to x. Okay? So if we just have, this is all about just x. This is just your general greatest integer function. What's the vertex for that? Is he going to snore in a minute? Getting close. Do we see an x?
No.
Do we see a y?
0,
0, 0. So we start at 0, 0.
Is it a closed out or open?
And it's going to be a closed. It's opposite for the pure.
Opposite of what?
Opposite of the reality. It was circled and closed. Just your regular graph is closed and circled. Because you can look at that and know that the vertex is 0, 0. So it's a fill in. And then it's going to go over to one dot and it's going to be a circle. And then we go up to 1 and go to 2 and circle. And so forth. And it can go traveling all the way up.
I don't understand why you got to give no numbers.
Yeah, I don't understand either.
Well, it's like, what number really is in front of the x?
One.
A 1.
So every time
And then it's like a step. It's step function. We're going up one number. It's like slope. Your slope is 1.
How do you know it's a closed circle and an open circle?
Because your vertex is 0, 0. We can fill that in. I mean, because there are no numbers given, so you know that the vertex is 0, 0.
what is it?
No.
Don't bother her feet. Her body.
GIF mean?
Oh, greatest integer function. I just used it.
What does that have to do?
That is, when you have, thank you for, all right. Notice our x. Our x is sitting inside what? Not absolute value bars.
Bracket.
The hard bracket. Okay? That is a denotation that it is GIF, that it's the greatest integer function. All right? So, which is just stair steps. Find your vertex and begin stair stepping. Okay? Fill in, open. Fill in, open.
So number 3 is at 2,
What's your vertex?
2 zeros.
Positive 2, negative 2.
Wow.
No, I'm asking, is it a positive 2 or a negative? Positive, because it's a minus, opposite H.
Is it a closed circle?
So we start off with a closed circle because we can see that and then there's like a plus 0 out there. That's given. So we go on our x-axis and we do a fill in and go to 3 and put a circle. And then a fill in at 1 and go to 4 and do a circle. A fill in and a circle. Fill in and a circle.
So if your A is like, this wasn't 1 right there, would you, like,
Okay, I think from what I have, the A is going to actually, if it's a 2, it's cut in half. And if it's 1/2, it's doubled. But look at me. I am never going to ask you that.
so we're all
You
always
don't-
gonna go 1 over 1?
Yeah, you don't have to know that. I am not going to throw an A at you, okay?
If
But
it
just-
was a positive 2, 7, negative 2, would you do negative?
Yep, yep.
What is that?
How do you what?
I just like don't understand.
Or how do you know what?
Like, how do you know it's always opposite? Is it always
Opposite HK. Vertex.
Okay, so once you get the first one, you just go.
Just step it.
So there's
That's
no,
it. No, no.
Like, why is this different from the first one? It's open
We had -2, which gave us an H.
if it's negative, you go to left.
Uh-huh. No, if it's positive, you go to the left.
So positive, it's open, closed.
Opposite H. I'm sorry, say it one more time. If it's
I don't know what you use open and closed.
If it is a pure graph, that means you've been given the vertex, right? So it's a closed circle. The only time it's open like this if it's a real world problem. Because when you walk, like this was an auto shop, and when you walk in the door, when you walk in the door, you handed them money.
Is it always gonna be open closed?
If it's a real world problem, when you walk in the store, do you owe them anything yet? Not yet, so it's a circle. But you're going to pay them eventually. But if it is just a pure graph, it's a vertex, so it's closed. Now, what did we say about X? GIF is what? Less than or equal to your value. All right, this is where, y'all, you're going to go, okay, what? So we have to have integers, right? So, well, this is getting even easier. It says, what is f of x? What is f with x being 3.2?
If X, it would just be
What is f? What is x?
3.
How'd you get that?
Yeah.
Less than or equal to? 4.
wait, the next one, where are we rounding?
You step down.
You never round all
Nope,
round-
always. That's why I was saying a minute ago, remember to round down. Remember to round down. What about f?
-2.
Negative. Good, Morgan. Remember, we're in negative land. I know.
So what is it gonna be?
Negative 3. Because negative 2.3, and sometimes having a number line helps. Negative 3, negative 2. Where does negative 2.3 would be about right there. And to the left is negative 3.
Wait, okay, so this is going to be like some of these,
No.
and then
Uh-huh.
one of these, and one of these, and then this.
Go down, round down,
I
right?
have a question on this.
And I'm not through. We've got more. We're not through.
So if it's a positive for these,
I remember one time
if it's a positive number, you round down.
Y'all, please.
If it's positive, you round down. If it's negative, you round the number up.
It's down. It's to the left on the number line. It's,
You can think in order.
oh, I see what you're saying.
If it's negative,
Negative, you're going to the left on the number line every time, which is,
Rounding down, you're
it's still bigger looking number. Yeah, farther away from 0. All right. I'm not going through this. Why do you know what?
you just round down.
You just
Because math.
because it is telling you that your GIF is less than or equal to your X value.
So how is the only answer?
And you're going to the lowest integer. So if it's 3.2, it can't be, y'all, shh, it can't be 3.2. Okay? Because it has to be an integer. Integers are whole numbers. No decimals, no fractions.
Okay, so wouldn't it be like 2 because it's your greatest integer?
So yeah, it can't be 2 because then it would be, for which one? Wait.
It's like on number A.
All right, A is 3.2.
Yes.
That on a number line is between 3 and 4. Like right there. So you go to the left. You go to 3. And 4.5 is between 4 and 5, but we're going to go to 4. You always round to the left. All right. We've done the back. I'm not going to graph these. I mean, absolute value, a constant is going to be your horizontal. Number 6 is just your line going through 0, 0. Because I want to get to this page.
Wait, so before you do that, Mitch, what do you do if it's an absolute value, Boris?
What?
Like, what is that? If it's x an absolute value versus the number 4, how do you do that? Wait, I'm not on that page.
We only have to sign.
I know. I did not print this.
Wait,
Are
can
you
you get
on
a,
Piecewise?
can you get a number 4 on this page?
Where's my number?
It's on this page.
No, it's in this packet.
Oh, we're coming back to that in just a sec. Have your calculators out.
Wait, is the piecewise not just like
I'm going to go back. Good. I'm not going to do. Y'all can have these to kind of look at. Now we're going back to the Piecewise packet. Y'all can have these for extra practice.
Will you post the answers?
Yes, I will.
I'm just confused on the absolute value.
The other one.
Oh, absolute value bars. What do they look like?
If it's an absolute value bar and x, and it's -3 is less than x, and then x is less
But
than
what is what do absolute value bars look like?
this.
Wait, so would it start
This.
with
So that means your graph is going to look like
Yeah,
this.
I know, but if it's x, it doesn't have a number.
Absolute values are always yes. Thank
So
you.
0, 0, and then just go up one every time.
All right. And if you don't know, put numbers in. You can always substitute numbers. Put in a -3. Absolute value would be 3. Divided by, work it from there. Back to this. All right, you got your calculators out?
Is our quiz going to be calculated?
That's all that is.
I'm thinking. All right, good question. Look at number 4. Have your calculator in your hand. Turn it on, obviously. Mine's not on.
Ooh, wait, emergency. If
Oh, come on, turn on.
it has, no, this is actually insane. You gotta see this. Okay. Yeah. That's absolutely value of x. -3 is less than x. So that
Let's
means
go.
it's greater.
Let's look at this one
No,
together.
no, 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 no. But listen, like this is actually wild. This is a open circle because it doesn't have the line under
Uh-huh.
it. But this is a closed circle and
Uh-huh.
it lays on the same thing. So what do you do?
Well, you're going to open and you're going to close. Which
can't
one's
do
closer?
both.
Yeah, you can.
Oh, you just close it.
All right.
This is like a wild like.
All right. So you're going to go to your calculator. And left. That was funny. Oh, there it is. Go to your laptop. Y'all listen all the way through while I did not hook mine in just yet. Hit graph.
Our laptop, what?
Wait, this is
Go to your calculator. I'm looking for this. Y'all, please don't talk. We've got way more to do, and I don't have time to chit chat. Go ahead and clear Doc B.
Dr. Jim.
I want you to hit, the little tab button here for graphing. Come on, computer. And NOV.
We should have the regular graph button. It's like F.
Fund. Inspire.
Can we plug this all in our archive thing?
Wait, but how do you? Like,
I'm trying to get it open so I can show you.
What's happening to where?
Inspire.
Wait, how do you make it do the constraints though?
Just hang on. I'm going to show you.
You're gonna have to figure that
If I can get this blooming thing to open. There we go. Yay.
What's in there? Reach your hand in.
I wonder if this is going to, I don't know that this will record. All right. I'm coming over here. We're at, all right, are you at f of x?
Yes.
Okay. You're going to go to this template button. It's just below delete to the left. Either move or quit talking and laughing. Now, how many on let's do number 9. How many do we have? How many equations? 3. So you're going to come all the way over here to the big bracket that has the 3 sitting. Template is bottom left below delete.
It's like with a fraction.
Yes. And then you go way down over here to the right and see where there's 3, the bracket with the 3.
We can
Create piecewise function.
Mhm. And then you're going to create OK. And you're going to come, see how it's something, comma, then another something, comma, another something, comma. This is where you start typing.
And you just
So-
type it all in.
Do what?
And you just type it all in.
Uh-huh. So absolute, do you know where your absolute value, your square root button is? That's Control X squared. And then we're typing a negative. In parenthesis, x plus 1, close parenthesis, and then I'm having to move it out just a little bit. You don't want your minus 1 to be underneath the absolute value bar. And then you're going to go over. Now, if you hit Control equal, and I could probably move it back just a little. There. I did a negative. I did a subtraction.
Wait, how did you get it out of the?
I hit the arrow, this arrow, the right button. This will let it move over just a little bit.
Why do you know to do this if the computer doesn't?
And then here, hit Control equal, and you have options. So, I didn't type X. Sorry, my bad. I needed to have typed X first. X. Stop typing so many. And then Control equal, and we'll do less than negative 1.
How do you open this?
No, this is taking.
And then tab
Wait, why did you press tab?
to get to the next equation.
You not just go down? Use your arrows?
You probably can. I just always hit tab. I don't know.
Yeah.
X
Oh, my.
minus 1 parenthesis
You forgot a negative.
squared.
Where? In front of the 1.
Whoops. Plus 2.
Wait, mine goes down too.
Wait.
Maybe you did it wrong.
Negative 1. Oh, okay. I didn't mean to hit you. Go away. Negative 1. It's because I didn't finish filling it in. Negative 1 is less than.
Wait, just me and Harper put the same thing and we have a different graph.
Are you through?
Yes.
One of it goes up and the
Just let
other
her.
goes down.
Make sure, go back and look that you typed it all in just so. One of you may not have, because you won't get different graphs. Make sure that you use the or equal to.
X plus 2, X plus
I was going to say, you got to have it just so.
Mine's just said.
I didn't.
Mine's
And this is 1
She's just said.
mine's just
That
x
Because ours all feels the same.
is greater than
Let me see, Claire.
why does mine go down?
and 3.
Because
3. Enter. Okay. Yours should look something like this.
Yeah. Mine that goes down, that line you're on.
It's because I think. Well, that wouldn't matter. She would have multiplied -1, but I didn't.
All right. Are y'all to this point and you're good? How we got it typed in. All right. Notice for number 9, you were told to evaluate. H of 0, H of 4, H of 2, H of 7. We don't know which graph those go with. So by hand, you would have to figure out, well, which parameter would contain a positive 3? Which parameter contains a 0, a 4, a 2, a 7?
Wait, Dr. Graham, I keep getting.
I don't know, baby, but I'm running out of time. I've got to show you this. You got to type it right. Now, there are 3 ways you can answer this without having to do the math, like of going and figuring out which graph they land on. One is a table, and to me, that's the easiest. So, you're going to go on your handy dandy to menu. Don't change your graph. Go to, all right, I'll back up 1 second. You can go to Scratchpad, and since this was an F of 1, you can type in F of 1 and put it in and hit enter. But you can also go to menu. 7, split screen table. Okay, did y'all get there? How not? Menu, 7, split screen table. Now, you were told that H needed to be what? 0.
Wait, menu table.
Menu 7.
So, look at what happens when you find 0 under X. What is your piecewise? 3. There's your answer. I moved it up. I went over to the X. And then for 1, what's our answer? What's 4? 4 is what? 1. For 2, it's what? 3. For 7, 1. So you can evaluate that way.
What about negative?
What about what?
Negative 1, it says like hashtag.
All right, -1. Undefined. That means it'll look like this. Undefined. Go to -4. Did it give you an integer? Because you're supposed to have integers for this.
Yeah, I'm at 40. I got. My F of 1 is not as much.
All right, no. So, -4, that one's not going to work for us.
My negative 4 is 1.41.
Mine is 2.
Mine's point.
It's 0.732051. Y'all did something wrong with the other part. So what you would need to do, guys, is actually plug this in. But I'll tell you as a hint which one it is. It's the top one.
Wait, so if you get a non-integer, you can't use
You got to fix it. So what is, if I -4, what is -4 plus 1?
-3.
-3.
So 3 minus 1.
And then -3 times -1 is
3.
3. So it would be radical 3 minus 1 would be your answer.
Okay, and then for 5, you would do, it's just 1. -5.
-5,
So it goes
1.
3, 1, 3, 1.
Radical 3 minus 1, undefined 1.
Because you have to plug it in.
I went ahead and just told you which equation it would be. It just happens. All right, we're looking. Wait, yeah, it will. Look, Claire, -4. Is -4 less than -1? So that's the one it goes in. Because -4 is not greater than 3, right?
We have homework.
So does that make sense?
If what we put in the calculator.
Wait, get your paper out. See, you're looking for -4 as an X, right? So -4 is greater than 3. Not -4 is less than 3. Yes, but it is not greater than -1. But it is less than -1. So I would do -4 plus 1 is -3. -3 times -1 is just 3. And then the radical 3 and then minus 1.
Wait, so our quiz is on.
Evaluating.
Okay, so I need to know how to do.
Have your piecewise.
Yes.
Domain and range for piecewise.
1 to 3.
Uh-huh.
And then, wait, is that right? Is that one right?
Yep.
Yeah, so for the domain and range, that would be negative infinity.
Wait, so that last part will be on the quiz?
Yeah.
Domain and range.
And then, just these.
Yes.
Are we gonna have our calculator go away?
Wait,
I'm
can we use
debating.
the calculator on the quiz?
Will you use the calculator? Yes, but maybe not the whole thing.
So like only part of it?
Probably, maybe part of it, maybe.
So like this, wait. This will be calculator. And this one, and this one.
That won't be calculator.
This will be calculator and this Willer will.
What I may have you do is graph and then check the graph.
Okay.
So you can use it, you know, to
So
make
I-
sure that you get it right. Now, what I do notice on the graph, it doesn't make a circle. It just is
So,
there. So you, yeah, I don't know why.
So just make sure that.
Make sure your endpoints
And
are,
then if a fill in and circle on the same exact line, yeah, it's always a fill in.
fill in trumps.
Wait, and then if it's two fill-ins, it doesn't count. It's not included. If it's on the same line.
Same line.
So you still do a union. Okay. But then if it's a fill-in, you don't do.
Correct. If it's circles, you use the union.
Okay.
So you just repeated the same sentence.
Nah, but you gotta add a inflection. So it's like buffalo, buffalo, buffalo,
Y'all have your
buffalo,
application.
buffalo,
Couple of homework.
So wait, what's the page? The homework from 2 nights ago. And
And
then
the
I'm
whole
sure I did it. But
Where's my dad?
What class is it?
Right there. Like,
You're touching it, I think. Just twirl it.
Annalise.
Seriously? That's right, it's behind my desk.